everyone, welcome to CHM Classroom with Auntie Taiwo. Okay, the last time we talked about oxidation, we talked about valency, and I showed us valence electrons, how ions are being formed. So today we'll be doing radicals. Yes, radicals, and if time permits us, I will show us how radicals actually combine to form certain compounds. Okay, so radicals are a group of atoms that carry charges. They either carry a positive charge or a negative charge. So for example, our CO32 minus, OH minus, SO42 minus, SO32 minus. Then we have some of them that are actually positive, like the ammonium ion, like that. So radicals, there are some of them that carry what? Positive charges, and some of them actually carry negative charges. And when this happens, I told us in the last class that these ones with negative charge, the ones with negative charge, they are the ones receiving electrons, while the one with positive charge would give out. So now what this means is that, you see this CO3, it will look for an element that is willing to give out 2 electrons. OH also will look for an element or another radical that is willing to give out what? 1 electron. Okay, let's look at sodium. Sodium has 1 electron at the outermost shell, like I said the other time, so it will be willing to give out 1 electron. So if I have sodium to be positive, only 1 electron, then OH to be minus, only 1 electron is in need. So it will be easier for sodium that has 1 electron to give out 1 electron to OH minus, because OH minus needs 1 electron also. So that is how our NaOH will be formed. That is how NaOH will be formed. Then we have some other ones like our Na2CO3, like sodium and CO3. Now what will happen here is a bit different from what happened in the first one. In the first one, they have equal number of electrons to give and equal number of electrons to receive. This one have 1 to give, this one have 1 to receive. But in the case of sodium and CO32 minus is not in the same proportion. Sodium has 1 electron to give, while CO2 has 2 electrons to receive. So automatically we are going to produce another sodium atom. So adding 1 sodium atom means 1 electron is here, another electron is here. So if we add up these 2 electrons, it's going to give us what? 2 electrons from 2 sodium atoms, and they will now give to CO32 minus to form Na2CO3. Yeah, I hope we understand this concept of formula formation. Okay, so which one can we try again? So you can also merge. Okay, let's try calcium and OH minus. Calcium and OH minus. Okay, now calcium is 282, is 22882. So calcium will be willing to give out these 2 electrons. Then OH minus, this is the hydroxide ion, will be willing to collect only 1 electron. Okay, but calcium has 2 to give. Calcium is generous. You understand me? It's generous. So if calcium gives 1 electron here, it will still remain 1. And calcium is still willing to give, of course. So I'm going to produce another OH minus. So that these 2 OH, we need 2 that will fit in for what calcium is willing to offer. So if we have calcium, then this OH now, two of them. So that is how our calcium hydroxide is being formed. So when next we'll meet, we'll be discussing IUPAC naming using the oxidation number